Oh my goodness, oh my goodness. Wicked. Excellent. 403 to the HAZ. What's going on? Here's all time. Okay. My beautiful pre-cal 12s. Beautiful little babies. So we're talking about combinatorics, just combinations, which is essentially how we're investigating the different ways we can arrange objects, right? So basically, if I had the words, the letters C-A-T, how many different ways can I arrange these letters? I can go A-T-C, T-A-C, blah, 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 blah. And we, in the last video, we were talking about the fundamental counting principle. And I could choose, so these are the different slots for the three letters. And I could start anywhere. And if I decide to start here, I have three options that could be. It could be C, an A, or a T. But as soon as I choose one of those letters, the next slot, wherever I choose it's going to be, there's only two options. And finally, the last slot is one option. And I can calculate all the different possibilities by multiplying those together. That's the fundamental counting principle. Now, we like to just work in order, so when we do see it normally, we see it like this, ordered out, and then we learn that we can call this 3 times 2 times 1, that's 3 factorial. So there's 3 factorial ways of arranging the letters C-A-T, because there's no repeating letters, and we don't have to worry about any of that stuff. Now, this is an example of a permutation, okay? And a permutation is basically, it's counting the ways, it's an arrangement, it's a way of arranging objects, but permutations means that order matters, okay? Order matters. And, well, what does that mean when I say order matters? Well, there's 2 scenarios. Imagine that I had 30 players, okay? 30 players, and they're trying out for a soccer team. And there is 5 positions on the soccer team that they're vying for, okay? Now, and we're going to talk about this in future, there's combinations and there's permutations. And we're going to talk about combinations in the future. But an example of a permutation, so there's 2 ways we could do this. If I said you had to choose 5 players from this team, if it was a combination, it's just how many different ways can I choose 5 players? And I'll have five groups of 5 unique players, right? So that's a combination where I'm just choosing 5 out of the 30 so that each group of 5 that I choose is unique from the last one. A permutation, however, if I'm choosing 5 players, a permutation would be like, but I'm choosing for positions. Center, left wing, right wing, defenseman 1 and defenseman 2, okay? Now, if who I choose for each position is, so if I have one situation where I have the same 5 players, but they're having different positions in that combination, that's now a permutation because the order that I'm choosing them for each position matters. I'm not just choosing a group of 5 players. So, a lot of talking, and I'm hoping I'll be able to round it out. But all I want us to learn in this video is that when I'm doing this situation, where I'm using the factorial, I can also use the permutation syntax, which is n permute r. Okay? And in this case, this is equal to n factorial over n minus r factorial. Okay? Now, n is the number of objects I'm choosing from. Number of objects. So in the case of CAT, I'm choosing from three objects, 3 letters. 1, 2, 3. That's the amount of objects I'm choosing from. And R is the amount choosing from. And R is the amount of objects I'm organizing or I'm arranging. I'm arranging. So in the case of here, I'm arranging as many letters as I'm choosing from. I'm arranging all three. So this I would write as, in this case, for this example, I would write 3P3. I'm choosing from 3 letters and I'm trying to arrange in groups of 3 letters. And so I would write this out as n, which is 3 factorial, divided by 3 minus 3 factorial. And I get 3 factorial over 0 factorial. And 0 factorial, there's a rule, 0 factorial is 1. It's always 1. 1 factorial is also 1. So this is the same as 3 times 2 times 1 over 1, which is 6, which is the answer we had up here, 3 factorial. So why this way more complicated way of doing something we did so easily here? Well, what happens now what would happen if I had also a few more letters here and I added the letters P and S? Okay? And I said, how many 3-letter arrangements can I get from these 5 letters? Well, now I'm only choosing 3 at a time from the 5, but the order that I write them in is going to matter, right? Because I'm concerned about how many. So if I chose CAT, if I chose TAC, if I chose T first, A second, and C, this would be unique from this, right? Because the order matters. Now, it would be a combination if it didn't matter what order they're in, right? So just choosing the letters CAT is the same as choosing the letters TAC. Doesn't matter what order you choose them in. But in this case, the order we choose them in is going to count, because we want to see how many unique 3-letter words or strings of letters we can get. So in that case, I am choosing from 5 letters. So my n is 5. So I'm going to write 5 permute, because the order matters, 3. I'm pulling 3 from my 5, and when I do that, I get 5 factorial over 5 minus 3 factorial, 5 minus 3. And I get 5 permute 3 is equal to 5 factorial over 2 factorial, which is equal to 5 times 4 times 3 times 2 times 1, divided by 2 times 1. That cancels with that. And I get 5 times 4 is 20. I get 60. I have 60 different arrangement possibilities of 3 letters that I can get from those 5 letters. And that's what a permutation is. And in the next video, we're going to learn what a combination is. And that's simply when I have NCR. Okay? And the C means I'm choosing. So in this case, if I didn't care what order the letter is in, I just want to know how many ways I can choose 3 different letters, 3 unique letters, combinations, then I would be using this. And in that case, I'm going to have less possibilities because the order no longer matters. If I pull CAT, well, that's the same as if I pulled TCA, because the order doesn't matter. So that's, in that case, I'm going to have less possibilities. And that's the combination side. So we're learning about permutations where the order matters, and then we move on to combinations where the order doesn't matter. And we will do tons of examples. I just want to give you guys the syntax here so that you can go ahead and start tackling the textbook problems. Okay, good talk.